This is going to go through kind of how to do these Hardy-Weinberg equations. These are actually the questions that were on your lecture exam or lecture quiz this week. And so what we have are the equations. Remember that for the allele frequencies, we use the P plus Q equals 1, and then P equals our dominant allele, and Q equals our recessive allele. And then when we look at the Hardy-Weinberg equilibrium genotype equation, P squared plus 2PQ plus Q squared equals 1, then we can say that the P squared is the homozygous dominant. So P squared equals your homozygous dominant. 2PQ would equal your heterozygous, and then Q squared would be your homozygous recessive genotype. So if we look at our scenario here, so a population of birds contains 25 with red tail feathers and 75 with blue tail feathers. Blue tail feathers are dominant. So what does that tell you? That means that your blue is dominant. So that means that both homozygous dominant and heterozygous genotypes are going to be blue, which is going to be 75 out of 100. And then we also know that then red, which is recessive, we have 25 out of 100. Remember that a red phenotype in this case is recessive, which means the only possible genotype for this would be your homozygous recessive. That being said, if we figure out our frequency here, then we know that our homozygous recessive frequency would be 25 divided by 100, which is 0.25. So that being said, 0.25 then is equal to Q squared. Okay, so if we look at this again, blue is dominant, red is recessive, and I'm telling you that there are 25 birds with red tail feathers and 75 with blue, which means there's a total of 100. 25 of them are red. 25 out of 100 is 0.25, which is our Q squared. And so what we can figure out from that is Q, right? So if Q squared is 0.25, then Q has to equal 0.5, right? Because 0.25, if you take the square root of 0.25, then we get 0.5. And if Q is 0.5, and we look at our equation up here, P plus Q equals 1, that means that P equals 0.5 as well, because 0.5 plus 0.5 is 1. So this is some useful information. So I think these are a little bit out of order from your test that you had. But if we look at these questions then, so let's look at this one first. The frequency of the red allele and the frequency of the blue allele. Well, we just answered that, right? It's 0.5 for each of them. So that's going to be right here. Then if we want to see, so what is the frequency of birds homozygous for the blue allele? That's going to be homozygous dominant, which is the same thing as saying P squared. P is 0.5, which means that P squared would be 0.25. So that's going to be this answer here. And then lastly, what is the frequency of heterozygotes? Heterozygotes is, remember, going to be equal to 2PQ. So look, using our numbers here, that would be 2 times 0.5 times 0.5. And what's that going to be? That's going to be 0.5, which is kind of funny, right? So if we think about this here, it's actually going to look like this, 2 times PQ. And so 0.5 squared is 0.25, and then times 2 is going to be 0.5. So it looks like we actually have the same answer for each one of these, except for the bottom one. So I hope that kind of helps you. Again, you have to see which one is the allele, which one is the genotype. And when you read the question, again, you are given in the question the total population. You are also given in the question what is dominant and what is recessive. And so in this case, since red is recessive and there's only one possible genotype for the recessive trait, we can figure out Q and then go from there.